Hello friends, I am Avanti from Faculty of Engineering, University of Florida. Let's see how to demodulate the generated waveform using a spectrum analyzer. So let's go to the apps and we find the 5G waveform generator in here. If you can't find it, you can search it and find it. It takes a little while. And here, from here, I select the test model in new radio test model for 5G. Then you have to select the frequency range. There are two frequency ranges, and I select test model 3.5 uniform 64 QAM modulation, and here I select 20 megahertz bandwidth and subcarrier space in 15 kilohertz, and duplex mode. Let's see, select as frequency division, and then we have to click the generate button to generate the waveform. Here you can see the waveform, the spectrum. And so there are number of resource blocks, 106. And subcarrier spacing is we already select 15 kilohertz. Then we have to export this to our workspace. Let's export. And our export variable name, I call it as var. I name it as var. Then, so here we can see the export value. We can see type, configuration, phase, and waveform. There are in here the important thing is data in waveform. So how this generated waveform, this waveform data is some kind of OFDM modulated signal. So now we have to demodulate this signal. To demodulate our signal, we have to find a new radio demodulated code in or 5GNR. So here we have NR OFDM demodulate syntax. Since we are getting data from the spectrum analyzer, we get this one. We copy this code to our script, and the waveform is data we need. It is in var waveform, so we change value, and NRB is the number of resource blocks. We can find it in the spectrum analyzer here. There are 106 resource blocks. So 106. Then number of subcarriers. No, sorry, number subcarrier space is 15. We selected that 15 is if you have talked about this subcarrier space 6 kilohertz 15. So next one in initial in slot. So initial in slots should be 0. So our next in here we got grid. That means we got the matrix in 3D waveform complex, some kind of constellation. If we want to get some constellation, we can find it, get it like this way. So we have to plot this values in grid, but it is complex matrix. So all the rows in, let's see, 7 column. So and the values is denoted asterisks. So in here you can plot the values in grid, all the rows values in 7th column as matrix denoted by matrix. So then if we want to get the data about the plotted waveform, so how can we do that? There is a syntax inform or N this we get to copy the syntax here and place it here. So then it will give us the information about the OFDM demodulated signal. Let's run this code and see what happened. Here you can see the constellation diagram. I already said we in waveform generator I selected NRFM model 3.1, which is created for uniform 64 QAM. So there are 64 QAM bits, and the grid, you can see it here, there are 1272 into 140 complex doubles. We selected 7 column, so this column will select the data in this column will generate plotted in the constellation diagram, and it's some kind of multiple antenna things. There are 140 multiple antennas. In 5G, we have new waveforms such as universal filtered orthogonal frequency multiplex, filter band multi-carrier, and generalized frequency division multiplexing. So in that case, every OFDM symbol have to generate from one antenna and receive from one antenna. In that case, we are doing this kind of things. So, and also you can see the information, number of FFT, sample rate, cyclic frequency, symbol length, windowing, symbol phase, symbols per slot, some kind data. So if you want to change the values, let's see if we want to make it subcarrier spacing 30, you have to generate it again. And now you have number of resource blocks 51 and subcarrier spacing 30. So you have to change this. This is number of resource blocks 51 and subcarrier spacing 30. Before that, we have to export this values into the MATLAB script. So here, variable name, I call it as var1. Already exported. Then now here we should be var1. Then all done. We have to run this, and let's see. The values are different. We can see that before 2048, now 1024. Okay, the values will be different. Grid values also different. So that's all. Thank you for listening.